Hi, I'd like to introduce you to Riveredge Nature Center. My name is Stu Hanna. I'm a teacher naturalist at Riveredge Nature Center. My job today is to try to teach you a little bit about the pH test and then how to do a pH test. Of all the tests that you are going to do, it might be the easiest one. So it's a real simple test to do and has some real important things that we'll talk about real quickly. We'll show you how to do it, and then you guys should have no trouble whatsoever doing this on your own. First of all, let's just remember the pH scale, what pH is measuring, and again, I'm talking to quite a range of people here, anywhere from middle schoolers to high schoolers. If you've had some chemistry in your background, you know that pH is a measure of the hydrogen ions that are in water. In other words, what makes things either an acid or a base. So we set up what we call a pH scale. The pH scale, 0 in theory, would be a very, very strong acid. We'll never see anything like that in nature, we sure hope. And 14 would be a really, really strong base, or in nature what we call alkaline. We would never see something that high. We would have some serious issues if it ever got to be that bad. I'll give you an example. Between 0 and 7 is, of course, acid. It's acidic. If you look at the number 3, which is rated down by about here, that's where Visine is, that you'd use to get the red out in your eyes, which is a very, very gentle material. So you can see if we go from 3 to 7 or 7 to 11, we've just got a really sensitive scale that we can use to measure how many hydrogen, or in this case, OH ions are present. So just keep that in mind, that that's what we're looking at. Why is acid important? Okay, the pH in which any organism lives in, and we're dealing with water organisms, and I have some water here that we took from Riveredge's farm pond here. When we're dealing with acid, what we're looking at is this an environment that our living critters can be in, that they can survive, especially fish and things like that. They have to be in an environment that they can survive in that. The example I always gave my students when I was a teacher was there's a fish called the neon tetras that people can buy in their fish stores, and they're freshwater fish. They're bright blues and reds, spectacular fish, beautiful. Everybody likes to have them in their tanks. They put them in their tanks. They're beautiful for a week or two, maybe a month or two, maybe 3 months, and then all of a sudden they get weak and they die. The reason for that is that the neon tetras come from the Amazon area, and they like their pH down here about 6. In Wisconsin, we can never keep our water at 6 unless we do something artificially to do that, and the neons suffer. It's a great example of a type of environment of the water that is then going to determine what kind of organisms can live in that water. All right, in Wisconsin, and especially in the southeastern Wisconsin, which many of you guys are working, much of our stone is limestone. Limestone has a tendency to be alkaline, and so our pHs will have a tendency to drift towards the alkaline, towards, maybe 8, 9. I don't know that I've ever seen the number of 9. So somewhere in that range is what we're going to expect to see for pH. Okay? Now, we did have some issues down the road years ago with things like acid rain. Those, of course, were created by our power plants, was one way that it happened, especially in northeastern United States. We had a lot of acid rain that was drifting down onto our lakes and creates some acid problems. I think we have a better handle on that today. Things are in better shape that way, but those are the types of issues that can then greatly affect the type of wildlife that we'll see in that body of water. Okay? Now, couple simple things here that we want to do when we're going to do a pH test. All right, so again, you should use some sort of eyewear. That helps. I'm going to be honest with you, the chemicals we're working in here are really relatively very, very safe, so you don't have to fear that you're in a chemistry lab working with hydrochloric acid that's down there at a pH of 1. You're not. Okay, also, it's a good idea to have gloves on in case your skin or something like that is sensitive to it. But again, no matter what you would do after you get done with these activities, you're going to want to wash your hands really good and make sure that you're being safe. We're going to get a sample of water. You're going to go to your river, and in this case, we got the sample of water from from our farm pond here. All right, the kits look like this that you're going to use. It's a small, simple kit, really easy. It's got basically 4 things in it that you're going to see. Remember, each one of these kits always comes with a little card in it, and so it's a great cheat sheet. And so I'm going to go through the steps that you're going to want to do here, but you're going to want to just keep in mind that if you ever get lost or you're not sure what to do, please just take a look at this cheat sheet and you should be okay. All right, there are 2 plastic vials in here. Notice that in the plastic vials that you have small lines on here at different spots. There's a reason for these lines that are on here, okay? Then you'll notice that we have a black box. Inside of the black box is a color wheel. This is what we're going to use to match up our colors to get our pH, okay? And then we've got a chemical that we just add drops to, and we just see what the color changes. It just simply could not be any simpler than that. Okay, so let me take you through the steps that we're going to do. What we'll start off with is you want to always make sure that your tubes are completely clean. So, feel free to take the tops, off, put them in the water, rinse them out really good. You never know what somebody was doing with these beforehand. All right, so what you want to do is you want to take these viewing tubes that you have here. When you get your sample, fill the one tube up completely. That's going to give us the color of the water. The other tube, we're going to pour water into the 5 millimeter mark. The tube that I just poured the water, I'm not going to add any chemicals to this. I'm simply going to put the top on it, and I'm going to put this tube into the right-hand side where the colors are going to go. And what that does is this gives me a background color to the water. Okay? This tube then, we are going to add our 6 drops. So again, when we add our 6 drops, to open this container is hard to do. Push down and squeeze at the same time. Now take and add 1, 2, 3, 4, 5, 6 drops. Okay. Then stopper it. Shake for 30 seconds. Shake, 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 shake. Shake for 30 seconds. And when you're done after 30 seconds, put it in the right side of the tube. And now match the colors. And so when I match this, 7.5 seems a little light. 8 seems a little dark. So I'm going to take right between the two, 7.75. And that'll be my pH. That is typical in Wisconsin that we would get, because of the limestone, that we would see our pH somewhere in this range, just above 7. Our pond then here that we're looking at here has a pH in a very acceptable range for what we would expect life to be able to thrive in. You can see it's a nice summer day here. You can see all the things growing and stuff in here. They're flourishing. They're doing really well. So obviously the pH is acceptable here. You might think that that's typical all across Wisconsin or in the United States, and that is not true. I have a good friend of mine who taught out east, and he had a river that was crystal clear, just looked beautiful, just gorgeous, but not a plant, not a critter, nothing in it. And that was because when they checked the pH on that, the pH was somewhere down around 3, and nothing could survive that. And that was because they were getting washings coming out from a nearby mine that was causing that's acid level to be the pH level to be so low. So what you want to remember is that this is just a good indicator as to what kind of shape the river might be in for pH. That's all it's telling you. Now, the next thing you're going to do is you're going to use your blue books, or these books that you have right here that'll be supplied to you. In this book, if you go back, there is a series of pages where you can calculate just exactly what that means. Now, I used to always say to my students, the beauty of this research that this was done at the University of Michigan. And the University of Michigan came up with these results. And what they did was they took quantitative data, in other words, quantity, a number. Okay, in our case, 7.5 to 8. They took quantitative data and they turned it into a quality and they gave it a grade. I always told my students, it's just like a teacher. A teacher hands you back a test and they said, you got a B on that test. Where'd they get that from? Well, somehow they took data that was quantitative and they turned it into qualitative, which is a grade. So here's how you can determine your grade. Again, it's really pretty simple to do. We got a pH between 7 and 8, somewhere in this range. We take a straight edge, we run it up here until it hits this line, this curved line here. That's why they taught you this in math classes. You never use your math, but you will. This comes up to here, intersects, you run it across, and we get a grade that's about, an 89 or so. So an 89 would be B plus, somewhere in that range. Notice ideally we'd like to have our pH somewhere here, a little closer to 7, which of course is neutral, but that's not that critical. The critters that are in here can certainly survive. They're not going to have any problem. I would get done with this test. I'd look at my research, I'd look at my data, and I would say, I've got a pond that is acceptable for life. I'm good with that. I'm comfortable with those numbers. Okay? So really simple, easy test that you guys can do. I always like to start my students off with this one first because it was a really easy thing for them to do and get nice, easy, straightforward answers out of. Okay? That's it. So that's all I have to say about pH today, and we'll see you for the next test.